In this video, I'm going to go over titrations using strong acids and strong bases. So that's just one type of titration that you can have. So in a strong acid, strong base titration, there's two options. One, you slowly add a strong base to a strong acid. Or two, you slowly add a strong acid to a strong base. When you do these titrations, you can get titration curves, which show you the pH of the solution with differing amounts of volume of either your base or your acid that you've added. So I'm going to draw one here for the addition of NaOH to a solution of HCl. So y-axis is the pH, x-axis is the milliliters of NaOH added. I'm not going to put units onto the x-axis for this demonstration of the graph, but I'll put them in for the y. So let's say we have pH 2, 4, 6, I'll label that as 7, 8, 10, 12, 14. So in a strong acid, strong base titration, right, we're going to start at an acidic pH because we initially only have strong acid. So we start and we add some, but it doesn't really do much. It doesn't do much, and then boom. And then it curves off like that again. So the point right in the middle here, where we have the moles of our strong acid are equal to the moles of our strong base, this is the equivalence point. Right, for this reaction, the reaction is HCl plus NaOH to give NaCl plus water. So that's the point where all of the base has neutralized all of the acid. So the only two components we have in solution are the NaCl and then the water. And because sodium chloride doesn't have any acidic or basic properties, the equivalence point is going to be right at pH equals 7. So for any strong acid, strong base titration, the equivalence point is at pH equals 7. And again, because the conjugate base of the reaction, right, Cl minus, is not basic at all, right? It's not going to react with water to form hydroxide. So I'm going to go over an example to show how the equivalence point and the sharp spike right here is only in a very narrow range of volume, and that for the most part, when you're adding, it's not going to change the pH very much. So in this example, we add 35 milliliters of NaOH to 50 milliliters of HCl. And both the NaOH and HCl are 0.5 molar. So what we want to do is calculate the moles of OH minus we have and calculate the moles of HCl that we have. So for NaOH, we have 0.5 moles per liter, 0.5 molar, and 0.035 liters, right? That's 35 milliliters, and this gives us 0.0175 moles of NaOH. Then for the HCl, we have 0.5 moles per liter times 0.050 liters, and this is 0.025 moles of HCl. So if my moles of H plus are going to be 0.025 minus 0.0175. Because I neutralize 0.0175 moles of HCl from the NaOH I've added. So then I have an excess then of 0.0075 moles of H+. Now I have a new volume because I've added in 35 mils to the 50 milliliters. So my total volume now is 0.85 liters. So that's important. The volume changes with titration. So you always have to make sure when you're calculating the molarity, you're using the correct volume. This gives 0.0882 molar H+. So my pH then is going to be the negative log of 0.0882, which is 1.05. So even after I've added in 35 milliliters of NaOH, I still have an extremely low pH. All right, let's say I'm getting close to the equivalence point now. So now I have 48 milliliters of 0.5 molar NaOH that I've added to 50 milliliters of 0.5 molar HCl. So I'm going to calculate the moles of each again. So I have 0.5 moles per liter of NaOH times now 0.048 liters. And this gives me 0.024 moles of NaOH. And then I have 0.5 moles per liter of HCl times 0.050 liters to give me 0.025 moles of HCl. So that means my moles of H plus are going to be 0.025 minus 0.024, leaving me with only 0.001 moles of H plus. Divide this by the new volume, which in this case is going to be 98 milliliters, or 0.098 liters, to give a molarity of 0.0102 molar. So my pH is equal to negative log, and I'm going to get a pH of 1.99. So it's gone up from 1.05, but it's still very acidic. So what happens now if I add in 52 milliliters of NaOH? So I go past the equivalence point. Right, because at the equivalence point, that would be 50 milliliters, and we already know the pH is going to be 7, because the only H plus in the solution is going to be due to the ionization, autoionization of water, which is 1 times 10 to the minus 7th molar. So that gives you the pH of 7. So now I have 52 milliliters of NaOH, 0.5 molar, and I have 50 milliliters of HCl. So first, to calculate the moles of NaOH, multiply this by 0.052 liters, and this gives me 0.026 moles of minus OH, and then it's the same amount of HCl as we've had before, 0.025 moles of HCl. So now I'm calculating moles of hydroxide because I have excess of that. So this is going to equal 0.026 minus 0.025 to give me 0.001 molar hydroxide. So my POH is equal to the negative log of the concentration of hydroxide, which gives me 0.001 Oh, one thing I forgot. One sec. This, the 0.001, that is not the molar, that's the moles of OH minus. So probably some of you watching this caught my mistake right there. Right, I have to divide this by the volume, which in this case is 102 milliliters, so 0.102 liters. And this gives me 9.8 times 10 to the minus third. So that means my pOH then is going to equal the negative log of 9.8 times 10 to the minus third, which gives me 2. So pH is equal to 14 minus the pOH, which in this case is going to be 14 minus 2 to give me a pH of 12. So in just a difference of 4 milliliters of NaOH added, I've gone from a pH of 2 to 12. So if you're doing a titration in lab, you have to be very careful not to add base or acid too quickly, because the pH can change rapidly right when you get near the equivalence point. Now, if you add a strong acid to a solution of strong base, the process for calculating the pH is the same as I just did. And the titration curve will look similar, it's just it will be the opposite in terms of where it starts with the pH. Right, this time, so say we're adding HCl into NaOH, the pH will start up here, drop down rapidly, and then you'll have your equivalence point right here is equal to pH of 7. Right, so it looks the same, it's basically inverted because you start at a high pH and drop to a low pH as you add in more acid. So my next video on titration, I'll go over titration of a weak base with of a weak acid with a strong base, which is slightly different than strong acid, strong base.